video on solving systems of equations by graphing. By the end of this video, you will be able to know the difference between the different type of solutions for linear equations. You can graph the linear equations on the same coordinate plane, and you'll be able to determine the solution to a system of linear equations from the graph. Okay, so we're going to be using Desmos for this activity, so you're going to need to either have it on your phone or you're going to need to pull up the website. You're going to want to search for Desmos Graphing Calculator Georgia and use that one. Okay, what is a system of equations? A system of equations is two or more equations with the same variables. We could have a whole bunch of different equations, but we're going to limit ourselves to just two for our purposes in Algebra 1. Now, just like before, we were talking about the solutions to an inequality was any point that when you plug it in, it makes the inequality true and it's always in the shaded region. Or what makes a line true, there's a point that will make a line true that when you plug it in, it makes the equation true. The same is true for a system of linear equations, but because we're graphing two lines on the same coordinate plane, it's going to be where the two lines intersect. Okay, and there's really three ways that we can have this occur. So let's take a look. We could have one solution, and what one solution looks like is when you have a positive slope line and a negative slope line, and the point at which they cross, that's going to be the solution. The name of that point, when you plug in that x and that y into both of the equations, it will make them both true. So the lines are crossing for one solution. For no solutions, that means they don't share a point. Well, the only way we're having two lines that don't share a point is when they are parallel. Okay? So parallel lines have the same slope. It's another thing that we're going to want to know about them. And they will never cross because they have the same slope. They're starting from a different spot on the y-axis, but they have the exact same slope, so they'll never ever cross each other. And if they don't cross, they can't have a point in common. Now, infinite lines, infinite solutions, means they share all of the points. Okay? That means it's going to be the same line because they share all of the points. Okay, and so how you'll often see this drawn is you'll have a line with the arrows on the end, and you may or may not see the second line, but you'll see like a second set of arrows sitting on top of the first line, kind of like that. And they're sharing every single point in common because they're the same line. So we are not going to graph these by hand. We are going to be using Desmos. So if you have not opened Desmos yet, you're going to want to open it right now and then restart the video so you're ready for this. All right, we're going to try our first example here. And I'm going to pull up my Desmos. So this is the Desmos.com Testing Georgia Graphing Calculator. You can do this two ways. If you're on your phone, you can just tap the keypad. You can open it up with this little guy here, and you can type everything in here. I'm using a computer, so I'm going to use my keyboard. So you won't see me typing it in, but you'll see it show up on the screen. So when we look, we're going to take both of these equations and we're going to put them into Desmos. Desmos doesn't care if it's in standard form or slope-intercept form. You're going to type them in just like you see them. Okay, so let me pull this up. For the first one, we have y equals x minus 8. So I'd make sure I type in y equals x minus 8, and you see that the line popped up here on our screen. Okay, click right below what you just typed in to open up the next line, and we're going to write y equals negative 2x plus 1, and it's going to put the next line on there. So now remember, the solution is where the two lines cross. So if you hover, or you may need to touch it with your fingers if you're using your cell phone, it will name the point for you. The name of that point is 3, negative 5, where the two lines cross. So the name of our point where these cross was at 3, negative 5. That's the solution. If I plugged 3 in for x for both of these and negative 5 in for y, it would make both equations true. So I'm just going to do a quick little sketch here of this graph so I know what it looks like in the future. So I have my coordinate points, my plane, and then I had kind of a negative sloping line, and then I had a positive sloping line, and they crossed right there. They only crossed one time because two straight lines can only cross once. That's why it's called one solution. That's the type of solution that it is. So you should have your sketch, one solution, 3, -5. All right, so we're going to try this again with our second problem. So I'm going to go over to Desmos again. I'm going to pull that one up, and I'm going to just X out what was already there. Just hit the X's on the side, and I'm going to go back and type in. The first equation is x plus 2y equals 4, and it pops our line on, and you can drag the screen around with your finger or with the mouse so we can kind of see it a little easier. Click below the equation you just typed in and type in the second one. We get y equals, so that's a fraction. A fraction is division. So we got -1. On your keyboard you can just type the slash mark and it will automatically do this, or you use the division if you're using the keypad. 1/2. Now I want you to be real careful here. You have to touch to the right. Do you see how my cursor moved out from underneath the fraction before you put your X? So it's -1/2 x plus 2. Where'd the line go? Hold on. So look, we have the line there, and then I typed in plus 2 to finish the equation, and it disappeared. Well, what's really happened here, I'm going to click this blue circle right there. Click. Do you see how the line turns green? Now it turns blue. It's the same line. They're one on top of each other. That's why we can't see it. Okay. So when it's one line, so let's draw what that looks like. We had our graph, and we had one line, and then we had another line sitting on top of it. Okay, so they share all of the points, so that means there are infinite solutions. Right, for infinite solutions, how you write that, it's a sideways 8. That's the infinite sign right there. Okay, let's try it again. There's one change I want to make before we try this last one. I want you to change this 2, change it to an 8. It's just a typo. Change the 2 to an 8. So I'm going to pull Desmos back up again, X out what was already here, and put in the new equations. So we have x plus 2y equals 4. And then below that I have y equals -1/2. Make sure you come out from the denominator to put the x in, plus 8. Okay, so now looking at that, they're not crossing. So I'm going to scroll out a little bit. I'm going to go way out. And you notice how the distance between the two lines is not changing? We're 100 out. This is 100, positive 100x, negative 100x. We're pretty far out. The distance between the red line and the blue line or the black line is not changing. These lines are parallel. Okay, they're not ever going to cross. They would have the same slope. We just happen to have one of these in standard form and one in slope intercept form, so you're not noticing that they have the same slope by looking at the equations. So what that looked like was we had two lines and they weren't going to cross. You don't have to sketch all the time. I'm just wanting us to sketch for right now so we have an idea. So that has no solutions because they're not ever going to cross. So you can either write like NA here. If you do not write just a 0, because 0 is a number, it could mean you think 0 is a solution, but if you do 0 with a slash through it, that can mean no solution also. All right, so I'm not going to do the rest of these, all of them. I'm going to do, I definitely want to do number 5. It looks a little bit different because I just have y equals a number here. I want to show you what happens. Well, we can do number 6 also because that has x equals a number. So let's start with number 5. Let's go take a look at Desmos. I'm going to X out what was already there. So I'm working with a clean coordinate plane. And I'm going to enter x plus 3y equals -15. 15, and that's going to graph that for me. Click below it, and I have y equals -7. Now remember, y equals a number or x equal number is just a straight, either horizontal or vertical line. This says y goes through the y-axis at -7, which is what we're seeing here. So in order to do, I'm going to just do a quick sketch of that to help me remember for future me looking back on this. Okay. They are crossing once because two lines can only cross once, and they are crossing at this point there, which is 6, -7. So I have my sketch. I know they're going to cross at 6, -7, which means it has one solution. All right, one last one, and you should be ready for the practice. Pull up Desmos again. We're going to X out of what we've already put into here. And I'm going to put the problem in for number 6. So we have 3x minus 2y equals -18. So that gives me my line. Let me scroll that so we can kind of see it a little bit better. Click below the first equation and go x equals -2. So that's a straight up and down line. So real quick before I flip this over, I'm going to make a sketch of this. So I know I have a straight up and down undefined line. And then I have another line that's going to come through it. Okay, so I have my quick sketch. Looks something like that, just kind of giving me an idea. The lines cross once, so there's one solution. But the name of the point, that's the only thing I didn't get when I was over there before, so let's pull that up. The name of the point is -2, 6. Okay, so that's what we want to write on our paper. -2, 6. That's a single point that when you plug it into both equations, makes it work. Okay, your assignment is on the back of this page. Put all your answers in Canvas. Hopefully that was helpful. Let me know if you have any questions, and I'll see you in class.